We are live with Skot. I met Skot in Prague. You've heard of open source software, but how about open source hardware? I knew it existed, but it was a little new to me until I started talking with Skot about some things, studying up on more of that. And Skot is the instigator of the Bitaxe project, and he's on the board of the 256 Foundation. We'll talk about that. Building out open source Bitcoin mining ecosystems. So like Bitcoin itself, Bitaxe is fully open source with an onboard controller, lets you mine Bitcoin directly over Wi-Fi, easily configurable through the AxeOS dashboard. I'm running a few of them right here, right now. That's how I got started, and just dipping my toes in. So it makes home mining accessible. You don't have to feel like, oh, I need to invest a bunch or learn a whole bunch. It's a little more accessible and plug and play, and that's how I got started. The 256 Foundation, they raise money to fund developers building open source Bitcoin mining hardware, software solutions, dismantling proprietary mining empire, which has centralized Bitcoin mining around closed source hardware and software. This whole time up until today, we are breaking through that armor. So when I met Skot in Prague, given the work that he's done and is doing, I found him to be really humble, and yet he has an amazing story about the origin story of Bitaxe, the developments going on since then, the continuous hardware and open source community that he's building and working with now. So I really wanted to get him on the podcast. Skot, thank you so much for joining me today.
Fritz, thank you so much for having me. This is a pleasure to be here. I really enjoyed our conversation in Prague as we were like stumbling through the rain, trying to figure out where we were. It was awesome. I mean, we were just wandering and talking, but it was really cool. And your summary of sort of the project and its goals is perfect. So you're hired.
Good. I don't think people realize how closed. I mean, people realize, oh, things have become centralized or getting more easily centralized, and that's not just who's running nodes or who's mining, where the hash is. It's the hardware itself, and people are like, oh yeah, the hardware's a lot of it's from China, right? Oh, and even where the chips are made. Oh, TSMC, and who else? Samsung, kind of, not really, but a lot of this stuff is inherently kind of centralized, and yet what's the hardest part, the nut to crack in it all, in a way, is that, okay, say you can get the hardware, it comes like locked down, encrypted firmware that it's like a black box. We don't know what it's doing. There's stories about how big pools are just like, well, just get the hardware, plug them in, and then you run your layers on top of that and get your hash. What is that black box doing? Miners don't always know necessarily that firmware is just hashing. Is it doing other stuff? Is it connected to the internet and communicating what? I guess we just you can't entirely know what you're doing with not just Bitaxe, but the open miners, open source miners, and others, that you're hacking the world here, making it open source, making it accessible. It's not just for plebs and people dipping their toes in the water to learn and be decentralized, because that's a small number of the ecosystem. Big companies would also benefit from knowing, you have engineers that can look at the source. Well, then you can feel some security in your business model that what you're mining and how you're mining it is doing it what you say you think it's doing, and not maybe something else as well. The worst case scenario would be like a rug pull or something, or who knows, some weird geopolitical rift, war thing happens, and a Chinese company just shuts miners down, or this is all fantastical. What am I touching upon? Kind of the worst case scenarios of and reasons why all of this needs to be open source, and that in a way this is also inevitable.
Yeah, you got it exactly right. In the industrial mining scene, which dominates the Bitcoin network hash rate by a wide margin, right? They're solving all the blocks these days that are on the blockchain. We have some really large companies. Iron is one of the biggest. They're like a $10 billion market cap company. These guys are spending millions of dollars a month on electricity, and all of their revenue comes from mining Bitcoin. Well, I guess this is the AI stuff is on the side, but all their revenue for their mining operation comes from mining Bitcoin, right? And I can say with certainty, because there isn't a lot of other options out there, that the way that they're generating all that revenue is by plugging in these machines that they do not know. They do not know how they operate, right? They're these black boxes. And that's that is counterparty risk, right? We're talking millions of dollars per month on the line here, and you have this huge counterparty risk in that the black box that controls your whole operation, all of your revenue, you don't understand how it works. And this idea that something nefarious could happen, something malicious could happen, it isn't just a conspiracy theory. We actually do have examples in the past from Bitmain, which is the current market leader by a wide margin. I think best estimates put them at like 80% of the market by hash rate. So wide margin. We have examples. The most infamous one is called Antbleed, and it was discovered 2017. I think Bitmain had like 70% of the market back then. So still a massive player. And Antbleed was discovered by the community, and it was a backdoor in the firmware. And it would essentially allow Bitmain to turn off your machines or stop them from mining. All the machines, the firmware running in them, would phone home to Bitmain servers and essentially ask for permission to continue operating. And so,
wow,
yeah, right. This isn't just a conspiracy theory. We've had things like this before. There's a couple other examples of this like huge lack of agency that Bitmain has given their customers. There's the whole ASIC boost scandal that happened, where Bitmain implemented some new features in their chips, but they did not enable that feature in the firmware for all their customers. So this gave them a huge advantage in running their machines with ASIC boost enabled. And then we have, both ASIC boost is widely known now, and everyone seems to have access to it. Antbleed, as far as we know, is no longer operating, but we have this one ongoing now, this scandal, I would say, called secure boots, and it's a mechanism to prevent mining machines from running firmware that is not approved by the manufacturer. So the machines have a cryptographic element in it that will not boot firmware that hasn't been signed by the manufacturer.
So even if you try to rewrite the firmware or something, it's going to shut it down, like disable it.
It just won't boot. Your machine will essentially look like it's bricked, right? If you try to load this from a different firmware on there, this is like a way of controlling what you can and can't do, right? Because imagine if another sort of scandal like Antbleed was exposed, right? But there's nothing you can do about it. Your options are to either keep running at Bitmain's permission or turn off your miners. And these miners are very expensive, so you basically have to keep running them in order to pay them back. In a lot of cases, you took out a loan to buy these, so you really do have to keep running them. So yeah, I mean, Secure Boot really locks you into their firmware and the features that they allow you to use, and the upsides and downsides that come with that. Now, I will say that Bitmain's firmware is really crappy, and they have not implemented Secure Boot properly, and several people have figured out exploits to get around it. And so that's how we have third-party firmware like Brains, AxeOS, Finish, right? They have done an actual exploit to hack the control board and the firmware that's running on it to enable you to load other software. But with each release, Bitmain is, plugging those holes and is, working on implementing Secure Boot more completely, with I assume the goal of controlling, this is the only firmware that you can run on these devices.
Right. I mean, it's one thing to have like, okay, you've got a proprietary company, it's your business model, you want kind of a moat around your intellectual property, but that's quite an aggressive. Um, I mean, when it gets to that level, we're going to brick you unless you run exactly what we run. Is there a workaround to that? Is there a way, or I mean, do you have to unsolder the ASICs and put them back on a new board, or can you disable the piece of the hardware that does that lockdown, or do we know?
Yeah, you can, right? There's lots of tricky ways to get around secure boot, especially when it's not fully implemented like it is currently, right? They're working to plug those holes, and in theory, there's a way to implement secure boot properly. So you just cannot load different firmware or modify the currently running firmware on a device. You know, where we're at right now is that firmware runs on the control board for the miner. The control board is, you know, you can think of it as essentially a Raspberry Pi, right? It's got a ARM processor on there, and it's running Linux, and it's running this code. And then the hash boards that do the actual mining, right? Those are just sort of peripherals connected over serial. So and people have done this, is you can make a new control board, new hardware. That's over there. I was going to show you one, but yeah. You can make a new control board and then just not have secure boot, or you could, if you wanted to, do secure boot where you have the keys so you can sign the firmware. Control boards, you know, they tend to be $100 to $50, kind of depending on what they are. So it's an expense to do it, but yeah, that can be done now. I mean, there are ways. I don't want to give them any ideas, but there are ways that they could lock down so you have to use their control board. Luckily, we haven't gotten there yet, but that is kind of the override for this secure boot nonsense, is to make your own control board hardware that allows you to run whatever firmware you want.
And there can be kind of a cat and mouse game to that, where they issue, you know, new hardware, new boards, new firmware, and with every release, you know, we get them in, start diagnosing. No, what's different about this one? Like, they're not telling us per se. It's just secure boot or whatever. So learning again how to break through it. We're continually hacking the world. But I mean, here's my thought about it: is that I guess if you boil it down, the ASIC chip itself really is the critical piece. We need these ASICs. They're hard to make. They're all largely made at TSMC. And some elsewhere, but I mean, there's globally with every chip everywhere, there's a major crazy kind of a bottleneck, high commodity on chip manufacturing. That's its own little general question and concern risk for every industry. No. But let's just say the ASICs itself, I didn't realize this, how hard those are to come by. So even for like the Bitaxe and other projects, it's like, oh, yeah, I'd like to buy some ASICs. And it's either scrapping from people who are willing to sell piecemeal, or people are literally buying Watts miner, Ant miner, whatever, buying a bigger box and unsoldering them, right? Getting the ASIC chips out so that we can jailbreak them, put them on whatever you want, because the chip will work the right way. The chip does SHA-256, period. Yes. But it's the controller board, or like your Ember one, I think that you have now, that that then frees that chip to function for open source purposes and whatever we want to do really with it. So, is there a solution? Do you see down the road? Let's just ultimately, so we can force the Freedom Tech on the hardware level by just taking the chips off and putting them on ours. Now there's some work there, but there's value add, and I would call it value add. If you're a mining rig company and you don't want that counterparty risk, it can be worth it to perhaps do that so that you really know what the hardware is and that your business model is robust.
Exactly.
Is there a solution that you see? This is a big tangled problem, but ASIC manufacturing. I know that TSMC opened something or is building something in Arizona and elsewhere, but there's a lot of build out to do for a long time to get anywhere near Taiwan.
Yeah. I mean, TSMC is working on it. Samsung's also working on it. They opened a plant in Texas. Yeah, in Texas that they claim is going to be at 2 nanometers. So that's the latest and greatest.
Oh, wow.
Like you said, these are enormous projects. It's been said that these ASICs, not even Bitcoin specific ones, ASICs in general, like, AI processors for NVIDIA and CPUs for iPhones, right? These are the most complicated things humanity has ever built. 2 nanometers, which is like mostly a marketing term,
right?
What's that?
That's like the tiniest we can push physical limits about right now, I think, right?
Yeah, 2 nanometers is 8 silicon atoms wide. So
crazy.
We're using like atoms as building blocks here, like
right.
So it is not easy. It's a photolithography process essentially, but standard visible light waves are like hundreds of nanometers. So it gets really complicated. There's some amazing videos out there about how they do this stuff, but it is like sci-fi tech for sure. So all that is to say that building these chips is really difficult. I don't think this particular open source movement is going to be able to do anything there.
Mm-hmm.
But, one of the things that we can do to fix Bitcoin mining and help decentralize it is convince manufacturers of these chips, so not the foundries, but the companies that are designing the chips and getting them fabbed, to sell to people, right? Like that's the reason why currently for Bitaxe you have to unsolder chips or like get them on the like sketchy, gray market in China, is that Bitmain does not sell chips to anyone, right? They basically, all the chips that they make are for their miners. There's a small amount of chips that go to the repair market, but that's nowhere near the volume that we would need even for Bitaxe. So what we need to do is break that dynamic where the manufacturers of the chips only use them in their miners, where they'll also sell them to people who want to build miners, and preferably they will provide some documentation as to how to use the chip, because it's not easy. I spent years trying to figure out how to use the Bitmain chips because it is a actual black box. Not a lot is clear about how to interface with them. But, I think that these companies, these manufacturers of the ASICs, they can make more money by selling chips also, right? It's not going to cannibalize their, complete miner system sales, right? It's only going to sell more chips. The chips that they make, right, that's their moat. They know how to do it. The wall is huge towards anyone else getting in and undercutting them. So they can do what they do best, which is make these chips and just increase sales by selling the chips to other mining machine designers, manufacturers, et cetera, right? This is how the rest of the electronics industry works. If I want to get a voltage regulator or a level shifter or a microcontroller or something, right? There's a huge marketplace I can go to. I can look at these chips. I can get a $1 chip that has a 1,000-page manual because they want me to pick it. They want me to understand how it works so that I pick it for my next killer, project, right? So that Apple will pick it in the iPhone or something like that.
Yeah. They market and sell particular chips that do special functions, and there's a market for it.
There's absolutely a market for it. And they are hungry for those sales too, right? They will, in the rest of the industry, they'll send a guy to my office and buy me lunch and just talk to me about how to use these chips in an effort to sell me them.
Wow. Yeah. Now there's some inroads that I see with, like, say, Jack Dorsey's proto rig and some of that, where, okay, just trying to insert yourself into the business of TSMC is hard enough, but little inroads there where what I hope is that market forces show itself to be, hey, this is in demand. These are worth something. I mean, it is a crazy demand for these chips. So hopefully it opens up square footage space for creating these boards for the chips and manufacturing the stuff. And then it opens up over time that the market will prevail. And then, a Chinese company can't just say, oh, we just have a controlling share, and that is what it is. It's going to be more open market, and that goes away. And then if you have a choice in the matter, oh, we can only get miners from a couple of sources, and they all got a big aggressive moat around them. Nope. You have options. And even if you paid a little more for something that was free and open source, you'd say, yeah, that's worth it. And I would just hope that what I think is that it's inevitable, presuming that business functions the way it, is not otherwise controlled or has a grip on it. If market forces work, then all of this opens up. Open source is the way. That's what any company would want. Just so in my mind, paralleling what Linus Torvalds did to Unix and, Deck Alpha and these other big boys that were selling, big boxes of expensive, their flavor of proprietary Unix. And then Linux comes around and it's just like, this is free. I wrote a kernel. And and there's a community building on this stuff, and it just blew up, and the whole landscape changed. We were talking about being Gen X and seeing the changes through the years in the past, and what a time to have adolescence and learn about tech in the 80s and the 90s and all that. I can see the same, and I worked at Microsoft years ago, and I saw the proprietary wars over the operating system, the browser, any tool that came out, and they either bought you out or crushed you. And I was like, I'm out. But anyway, that was in the mid 90s, and open source is the way. We don't have to be beholden to a hierarchical control state. We need to hack the world. It's important that we have hackers like you in the open source community continually fighting this, and that you get support. I understand how in business it's natural that someone has an idea, it's intellectual property, they start making it, it's hard to do. Yes, you brand it or control it or do whatever you want because it's yours. Okay. And then over time, as it becomes more of a broad commodity in a sense, or a need that people have, I'm good with people hacking it, reverse engineering it, putting it out there, a new flavor. Hey, we built this from the ground up. We are making it free. And even if you have to be anonymous to do that, so you don't get like character assassinated or whatever, lawfare or whatever. It's, even as it's a battle, it's also inevitable. And hackers will fix and change the world in that regard. I feel really optimistic about it. You see it all trending up in that direction, right? Like there's hope, a lot of hope.
Absolutely. I think the open source development model obviously starts off slow, right? Same thing with Linux. It was this fiddly little project, right? I think Linus said it was, just created in his bedroom, but it has grown to control 90% of the internet servers over decades. But, and I think that development model, it really does make sense because it's permissionless, right? If you're in your garage and you're thinking like, I can do, what was Microsoft's web server, IIS, right? You're like, I can do something better. Mm-hmm. You got to get a job at Microsoft, or, pester them on forums and whatever to get your feature implemented. Whereas here you have something like Apache on the open source Linux side, and you can just do it, right? You just do it. You add what you want. You try things out. You're in your garage. Lots of these ideas go nowhere, but some of them do go places. And I think what we've seen is that exponential progress from people just trying things, releasing their changes, people building on top of those, and it starts to move really fast. And that's how we get to open source, essentially controlling the internet at this point, is that you don't need permission to improve on it, to deploy it, to start working on it. It starts off with the hackers who have an ideal and the free time and the, just nerdy desire to do these things, but it gets real very fast. And, the open source Bitcoin mining hardware is very much in its infancy right now, but we've already seen some crazy progress. What's happening with Mujina, what's happening with Bitaxe, and, the home mining market has been forever changed, but that's a tiny little amount of network hash rate. But we can definitely extrapolate this forward and see how it could easily take over, the whole mining market.
We were talking offline, and we all know it, but like, it reminds us how early we are. I mean, it was just 2023 that you really started, reverse engineering, working on the Bitaxe stuff too, right? And so, if just and it's been said, you've said it, but like in the wintertime, especially, in my office, inefficient buildings, whatever, any little space heater I see, it's just like, there's some wasted hash. But just electricity going to someone's warm feet, and or some cold room in a building, and all that waste. If just like 1% of those space heaters went towards contributing hash, the hash rate would double. And so
more.
It's just starting. So we're talking about the Hackers movie, and I got to watch that movie again, but we got to hack the world,
hack the planet,
hack the entire planet constantly, forever. The powers that be will always issue new things, but information and the human mind wants to be free. And that spirit is why we win. And sometimes it takes time, but we win, and we're winning. In the spirit of all that, I want to bring to stage here 256 Foundation. So started with Bitaxe, connecting with others, Discord, etc. Tell me about connecting with others. There's also the Open Source Miners United. There's this group here. 256 Foundation specifically helps raise money for a handful of projects. I'll get it. So on the hardware end, Ember One, you've built a lot on that. You mentioned Mujina, the firmware, and you had Schnitzel on recently talking about the development of the software in the firmware. The Libre board and Hydra pool. So much going on here. I love that OpenSats is helping you out. I think Mara helped you out. I don't know where to start, but and I want to get to your Bitaxe origin story too, which you've told like 100 times. But Ember One, this is kind of the current iteration of the reference design for kind of like what Bitaxe is, right?
Yeah, it's scaling it up. Bitaxe is, we have some newer ones now, but they're kind of just one chip, right? And it's a standalone miner, right? It's got a controller on it. It's Wi-Fi connected. It's running firmware on it. The idea with Bitaxe is you can just plug it in, and it starts mining. This is taking that open source idea and that customizability and all the good stuff that comes along with Bitaxe and scaling it up a bit. So a Bitaxe will be 20, 30 watts. This is targeting 100 watts, but it doesn't have a controller on it. So it's more like a hash board, like you might see in an Antminer. Antminers are, a separate control board like we were talking about earlier, and usually 3 hash boards. And the hash boards don't do anything on their own, right? They need a controller to feed it work, to initialize it, control the power, things like that. So this is a hash board design. Bitmain hash boards will be like 1,000 watts each. So this is a tenth of that. But it is designed to be part of a bigger system. So you could take, as many Ember One boards as you want, connect them up to a controller, and create a mining system.
Stack these up and add as many as you want, scale up, scale down, and it'll work. Yeah,
they're kind of cool because the Ember One design is connected over USB for data. So it gives you a lot of options on your control board. Like your control board could be just a Raspberry Pi. It could be your laptop if you want to, or you could take a purpose-built control board like the Libre board, which has a bunch of USB ports on it, and use that as your controller for an Ember One system. And so, it gets a lot of flexibility from that. But another important thing of both these hardware projects, right, is they're designed to be something that you can take and use directly. You can build them yourself or buy them from someone who's building them. Use it to make your own system that's tailored to your needs. But also you can take these designs and, remix them, hack them, like do what you want. Like, maybe maybe you don't need some of the stuff on the leaderboard. Maybe you need it to be cheaper, but you definitely want it to control the blower in your furnace, for example. So that might be a change to the board to interface with a thermostat in your retail space and control your HVAC system. And so the Libra board is very capable of being modified to do just that. And it could be a product, right? You know, this is something you could sell for these complete systems to target whatever you can.
You all are developing kind of a foundation from which economies and businesses can build. When I think of what happened with Bitaxe, where the plan, you help build and create the plans and put them out there, like, hey, here's the specs, here's how it works, here's what you can do, and built on that. Let's see here, was it here? Basically, there are a ton of vendors that all have popped up. I got mine from Solo Satoshi, but I remember looking at it for the first time going, wow, there's a lot of places I could get these from. I was thinking Bitaxe was a company that built these and sold these specifically. And I realized, oh no, this is the specs. And from this, companies have launched that do the hard work. I mean, not to say the hard work, but the hands-on work of sourcing the ASICs and doing some soldering or having a 3D printed housing and all the things. So
yeah, it's hard work. You're right. It's very hard work.
I don't want to diminish what you did and are doing but these companies are managing supply.
Yeah. Funny story. Years ago, I basically got the Bitaxe working, not entirely by myself. I had some help from some friends, some interested hackers, but we got it working. Right. And it was like, I had made a couple, hand built a couple of them myself to verify that it worked, but it was like, I published the plans. I was like, all right, revolution begin. Let's go. Right. And it was like crickets. People were like, where do I buy it? And I'm like, no, you just build it. And they're like, no, where do I buy it? And so it wasn't until these sellers came along, manufacturers too, and we're like, all right, we'll start building them. We'll start selling them, right? We'll deal with that whole stack. It wasn't until that happened that the project really started to take off. So I'm very grateful for the sellers, for the manufacturers that are, supplying the sellers, their units. It's better than I could have ever hoped, the way this has worked. We've got some really fantastic people that do a really great job that have spun up to support this whole ecosystem. And yeah, that's what makes it work.
It's awesome. And I don't want to be overly embellishing about how I look at this stuff. But when I first heard about Bitaxe and then understood how it was reverse engineered and put together and then others built on it, is it too much to say that sort of like Satoshi and the cypherpunks gave us the gift of freedom money tech on software? And what I see you and the heat punks and the open source mining collective folks and all the people working on Bitaxe and Mujina and everything else, this is like what Satoshi and the cypherpunks did now on hardware. So we're owning the entire landscape of all of this now, but it's as important, I think, because if we don't have control over the hardware, oh yeah, you can run software, but you still have a trusted third party or whatever, who knows. I just find this to be super important. I mean, I guess hence the passion and the mission of the 256 Foundation.
I would agree. It's super important. Bitcoin mining is an inseparable part, a very important part of Bitcoin. So, if we want to see Bitcoin succeed, we've got to have mining. And, I would argue that open source is an intrinsic part of Bitcoin. And you can't have decentralization without open source. And so we need to have this very important part of Bitcoin, which is Bitcoin mining, be open source as well.
The 250, I keep saying 256, 256, the 256 Foundation raises money to fund developers building open source Bitcoin mining hardware and software solutions, dismantling the proprietary mining empire that has centralized Bitcoin mining around closed source hardware and software. super important, and it's a thing that a lot of Bitcoiners just simply take for granted. It just happens. Miners hash. There's just ASICs that are made. They might think about how ASICs are made, but it's super important. And if you'll indulge me for a moment, when the 256 Foundation was getting started and started seeking funding, let me bring up, if I can here, I had there was a telehash that made the rounds. I saw it the day it happened, not live, but as soon as it happened, I realized, wow, this is incredible. Where is it? Yes. Do you care if I play this video here?
No, please do. That was a very exciting time. Oh my God.
This was an amazing day. And it wasn't until later I realized, oh, that was you with Eco. And is that Steven on there? Anyway.
No, that's Rob. He works with Bitcoin Park. He's an excellent host for panels. Definitely a friend of the foundation.
I have been there watching that stage with Eco. I've pet his dog. And anyway, when I saw this again, I was like, wow. And this was the first telehash you did, right?
Yes.
Okay. Do you care if I take a couple minutes and we can talk as well? But I want to play this because this was a magical moment.
Who knows? But you know,
there's also
blubbering
on
about
something.
Efficiency gains that can be had by just going after.
I love the edit done here because it zooms in on Eco.
We've been going for like over 6 hours at this point, live streaming for 6 hours to get to this point right here.
A telethon. And there was not a real...
It was at this moment that he knew.
You guys, we hit a block.
No way.
What?
You saw it live here on stream. Do we have a block number?
Yeah, we hit block.
Let us know. I'm pulling up mempool.space. Will you guys shout outside that we just hit a block? 881423. Congrats to Pod 256. We have hit a block.
It's just amazing.
You'll see it here. First time in known Bitcoin history that any sort of fundraising effort has ever solo mined and successfully hit a block.
The chances were not that.
I'm pulling up mempool.space. I want to read it right now.
Just mine an entire solo block.
This happened.
Yeah, we had
hit
like
a block.
1 exahash into the event. So
We
I think
have
we had like
hit
a
a
1 in 30
block.
chance for the whole day.
Shout out to Rod. We did it. We did it, buddy.
We hit
We did
a
it.
block.
It happened.
Let's go. Yeah, as this plays here,
We did it.
when I saw this happen, it was magic. And what it did was really kind of bootstrap, and it just propelled the 256 Foundation because it gave you kind of a launching pad, I might say, from which you now had some additional funding to say, okay, we can really start to go out there and do some things, for sure.
Yeah, we had spent the 6 hours that we were live streaming leading up to this point talking about ideas and projects we had for open source mining, right? And this foundation that was newly created by Eco and Rod, who kind of came in at the end there. They're the brainchilds behind the foundation. I actually wasn't even technically a part of it at this point. But yeah, we spent the whole time talking about, if we only had some money, like what could we do? And then it happened. And so like right after this, I mean, we got to work. We identified, we put out a call for people to work on these projects. We basically were like, all right, cool. Like Eco and I sat down, we're like, what are the projects we think could be very beneficial, and put out the call. Like, we're looking for people who want to work on, projects in these areas. Got back a bunch of good responses, started talking to people, and, dream team assemble. That's where Ryan, who's the head developer for Mujina, came in. Schnitzel, who's the lead developer for Libreboard, and Jungly, who's the lead developer for Hydrapool, came out of that process. So it was incredible to do this fundraiser, which was a total Hail Mary, right? Like,
Oh yeah.
we had been talking about so Rod and Eco had been running Pod 256 for a long time. And on there, they always invited people to donate their hash rate to the show. And then they would call out all the people that were sending hash rate. And it was kind of a small time fundraiser for the show. And they had been just sort of riffing back and forth. It's like, what if we did like a real event, like an all day event where we do this and try and see how much money we can raise for the new, at that point, 256 Foundation.
Yeah.
But it was like, he's an animal. He was just like, all right, it's happening on this day. And we're like, okay, all right, it's happening on this day. Let's do it. It was the end of January, I think, 2024. And it was 2025. That's right. It was January 2025.
Last year. Yeah.
And it just started coming together. Made some contacts with people who have a lot of hash rate. I'm like, hey, we're doing this thing. Do you want to point some hash rate here? We got one operator to commit to sending an exahash to the event. There was all sorts of stuff going on in the background of like actually getting the machines, pointed over to the node that was running the telehash, which was actually in the room. It was pretty cool. It was on a FutureBit device.
Awesome.
But yeah, it all sort of came together at the last moment. And the really cool thing is that the actual block itself was solved by a miner with like 20 petahash.
Wow.
So, there was someone sending about an exahash, but a much smaller miner from Megawatt in Indiana, they were pointing us some hash rate. They were there in the audience, and they just nailed it. It was so cool. It was really, really amazing. And we've done a handful of telehashes since then with significantly more hash rate and have not solved blocks. So we did really get lucky.
Yeah, it was serendipitous, like it was meant to be. It was supposed to happen. The spirit of Satoshi was there. The foundation got an injection and momentum. Just, okay, the signal has been sent. Let's go. And I mean, what a game changer. It was just, I wasn't even real familiar with the efforts and the mission of what was being started. And yet just to see that live, it meant a lot to me as an audience member, viewer online, just going, wow, what a blessing. So
it really was. I'm so thankful. I mean, that turned out really well. It enabled us to really put a lot of these ideas, to make them real and come up with these devices. And we have working versions of all four of the projects, which we've demoed working together, the complete stack, we like to call it, less than a year later, which is really neat to see. And I joined the board at the beginning of this year of the 256 Foundation to try and help, raise more money essentially, and provide some direction for open source mining and our goals and things like that. But the group of people that work with 256 are all a team, and it is so awesome. Our chat threads are just absolute fire. Our main problem right now is like picking one of these amazing ideas to work on. So it's a really cool thing. I'm super grateful for Eco who came up with this whole idea. Kind of alchemist, we call him Eco. And then Rod, who is the illustrious founder of Bitcoin Park and a huge guy in the community and fantastic person as well. They put this together and got it going. They've, did the crazy, in my opinion, work of forming an actual 501c3 nonprofit based in Tennessee, which is cool. So it is a proper nonprofit. You can donate to the 256 Foundation, and it's tax deductible.
Yeah, it's what can I say? It's just awesome that you guys are doing this. You have such a great team, and we still see solo miners occasionally winning a block now.
Yeah, there was one last week.
Yeah. It used to be such a rare, random like lottery thing, and now you're seeing them from time to time because one, there's just more Bitaxes out there. Mm-hmm. Two, there's there's text on the template side where I remember initially there was, Stratum, and it wasn't hugely adopted. And then there's Datum. Now we have Stratum V2, but it's empowering home miners to connect with, differentiating between solo mining and then pool mining. But there is solo pool mining where you can be part of a pool but have your own template, and you have control over your template, and you can dictate more about things there. But it's just opening up the capability of independent miners contributing and doing it the way they want, where and how and with who they want. And again, it's decentralization, and these solo blocks that are increasingly being won by random plebs is validating. It's at least quite validating in terms of this is all progress. So super awesome.
Yeah, it is. It's amazing progress, and it's only going up from here, right? The more people that get involved in this, the more blocks that get solved, and every time there's a block solved, more people get into this. So I'm looking forward to this compounding effect.
Yeah, and looking at the projects that 256 is part of, let's see here. Oh yeah, projects here. Okay, so Ember 1, we talked about that. The control board, Libra board, gives you more access and control to how you manage, and when you stack these things, how they work, what hardware you want to control, and how that all happens. Mujina, I've heard it. Is it Mujina?
Mujina, yeah, it's like a Japanese shape-shifting badger lore creature.
There he is.
Mujina is. That's our robot version.
It's like the Linux kernel of the Bitcoin mining firmware.
Yes,
I listened to some
really cool,
real technical talk just yesterday on the most recent pod 256, or the 256 pod that Schnitzel was on. It sounded like he was using AI and really playing around with the capabilities of what Mujina can do, and how to make it modular, I guess is the word, so that whether, when new chipsets come out, new boards or different chips come out, then instead of having to figure each one out and then building something new for the changes and little subtle things or whatever moat building occurs, the modular aspect, if I'm correct me if I'm wrong, but by having it more modular, it's more easy to integrate changes like that and not have to issue a whole full release of a thing to make it work. Is that correct?
Yeah, that's exactly correct. These are lots of issues that Linux itself faces, right? Because Linux needs to support processors, CPUs, right? All their peripherals, different things that people might want to integrate to a processor. And so it is similar with Mujina, because you could imagine all sorts of different mining systems that are configured in all sorts of different ways with different ASICs, different control boards, different external peripherals, different mining pool setups that you might want to go with. So there's a huge potential frame of things that it might need to support. And so Ryan, the lead developer on Mujina, he's an industry veteran in this kind of space working on this. And so he's really spending a lot of time on making the Mujina code very modular, such that it is easy for people to add on to it. And like we were talking about in Pod 256, with the advent of AI, now this really enables a lot more people to just try things. And so giving your AI a well-architected code base to start with, I think just makes it even easier to just screw around, find out, add stuff, plug it in, try it. And Schnitzel's been doing a ton of that with Mujina. He's a really cool guy. He's been working on mining heat reuse projects for a long time. He's the genius behind the Hash Tub, which is a Bitcoin miner heated hot tub.
Oh, nice.
And so, yeah, he's done a lot of stuff with hot water heaters and residential things. And so he's been, messing around with this stuff for a while. I've been following him for a long time. And so he gets it, right? He gets it. Like, if we only had a firmware that was built for these applications, it makes life a lot easier. We have the stock firmware and the third-party firmwares that are out there, but they are purpose-built for one thing and one thing only, which is mining sort of all out on the grid. That's great. I think they work very well for that. Obviously, I think there's some room for improvement, but where those existing solutions break down is when you're like, okay, you know, I don't necessarily want to control for maximum hash rate. I want to follow the power generated by my windmills or my solar panels, or I want to control for heat output to control my hot tub, right? It's like once you get it up to temperature in your hot tub, you do maybe want to ramp down the heat output of the miner.
Mm-hmm.
So there's all sorts of things that you can add there, and that really is the goal for Mujina, is to be the platform for these projects.
And for the techie folks out there, I have up on screen here. You can go to GitHub on the 256 Foundation. Mujina is available to download, look at the source, play with it, contribute, if you will. It's available now, even as it's being worked on steadily. What you got into in the conversations were interesting things in my mind, where not just the modularity aspect and making it, you know, people able to build on top of it more easily or change with different chipsets or boards, but that when you're, you know, when you're adding on multiple ASICs, there's a lot of technical things when it comes to power consumption, hash rate, the voltage that needs to be there, ramping up the frequency of how, you know, you can't just like, I think of it like plumbing. You can't just hammer some set of plumbing with all the pressure. You got to ramp these things up. And also you don't want latency or delays or wasted lack of hashing. You want the most hash you can get. You also want to push the chips for what they can really maybe do and not be throttled or governed by some, you know, proprietary black box. And yet when you distribute the voltage or up the hash, you do that in ways that don't create magic smoke or burn them out or are inefficient.
Ideally, yes.
And
yeah.
And also say you're going to drop the hash rate a little bit down for, you know, controlling it for whatever reason. It's not that, you know, a lot of miners will just shut off whole sections of machines and the rest are at 100%. You might actually diminish the hash rate for all of them more distributedly. Anyway, a lot of technical things around what goes into what's the most efficient, what's good for the chipset, what gives you the most control, and ideally also most efficient hash overall. So,
yeah, and it is still a reverse engineering project at this point, because we don't have any clear documentation for how these chips work. So, you know, there's the engineering of it, and then there's a reverse engineering of it. We're still learning a lot about how these Bitmain chips work. And yeah, I mean, I can tell you for certain that the stock firmware that comes with the AMP miners leaves a lot on the table. They are just operating them in essentially the most bare bones way possible. We've discovered all sorts of features in these chips that stock firmware doesn't utilize at all. So that's been really exciting to understand. You know, of course, Bitmain changes with every new chip. They change the features and what's available and what's not available. So it's a bit of a moving target.
Is there a risk at all to the ASICs themselves that something in there that we don't know? I guess by reverse engineering it, you're not going to accept or tolerate or tap into what you don't want to happen. But it might be that you discover, oh, this can do this or that. Could there be something in some of these chips that we might find out, like the previous backdoor things you described early on here that we talked about? Could we discover more in these chips that we didn't know exist?
Well, the previous backdoor things that we know about, some of which we talked about, those are all in the firmware, not in the chips themselves. So while yes, there definitely could be some sketchy, nefarious functionality in the chips, I think that the scale and impact of those nefarious features is pretty limited. You know, these chips, right? Their main goal is efficiency. So the hash rate per unit power. They want the best efficiency possible. And to do that, they have thousands of parallel cores, parallel hashing cores. There isn't a lot of room for other stuff.
Gotcha.
Right? If you were adding something else, I think the end result would essentially be reduced efficiency, and they,
It'd be
to
noticeable.
shave off like a single joule per terahash is a huge engineering effort. So I don't think that they would risk, adding something else to decrease the efficiency anymore. So I really do think that the firmware is the mechanism by which the wide majority of sketchy stuff would happen. That's the firmware is what's connected to the network, right? It's all in software. It's easier to change. The chips are really just these workhorses. They just hash Bitcoin block headers, and that is it.
Right.
So, obviously we stay frosty, make sure that there's nothing sketchy going on, but I really don't think so. I don't think that's a huge risk.
Yeah, and I think a nice vision to have, and maybe we're getting there, is that, and it's a cat and mouse game, but that sort of like when I think of graphene OS or something, or you're going to get a phone, but you need it for a very specific tailored function, and you want out of the walled garden. You buy an Antminer, you buy a WhatsMiner, you need to get the hardware from somewhere, and it would be awesome to take one of those, and instead of having to get into the guts of it, you could plug it in and connect your own bootstrap of sorts. Just wipe it, rewrite it, good to go. And so if you're a mining company, you get the hardware on a pallet, and you'd have a little process in there that you'd think, oh, this is a little extra work, but they go through I worked at places where we'd buy computers, and yeah, they came with all kinds of whatever, but we just wiped them. We ghosted them, rewrite them, and then plug them into the lab. Good to go. It's got our stuff on there. The hardware we understand and trust. It's the software we just want nothing to do with, or the firmware. You wipe the thing, you rewrite it, you plug it into your module, and it just goes. And then it's running everything that it is. And
that's the value add that you can provide to your customers, right? This is what differentiates you in the market, is that you can provide this, this high quality firmware or OS running on the device that is, free of all the crap.
Yeah. Yeah. These big mining companies that have their, stock annual reports on their stocks and portfolio and what they're doing to their shareholders and stuff. I bet there's some of them, they wouldn't want to mention the fact that like the supply chain of the hardware that they rely on is somewhat unknowable, or we are beholden to the hardware we get. But don't worry about that. That's just, it's worked for years. It'll always work. No, it would be a huge value add marketing thing to say, hey, this is all ours. You can trust it because we have the source. We can see the source. We can tweak it, fix it, always stay right on top of it. We've actually improved it. The list is endless. It's such a value add. I just think big companies, this isn't just me running miners here in my room. This is for big companies that, you would want to have complete control over your operations, and it's the core operations. So no, it's awesome.
Yeah. Can you imagine being in a shareholder meeting at your like $10 billion company and be like, all of our revenue comes from black boxes that we don't control?
Exactly.
Like, it's probably don't bring that up, but it's true.
No one bring up what the hardware is. It just mines. Don't worry about it. It just mines. And to be honest, I mean, even, engineers that work at these companies that have a specialty or an area, and they're working on layers on top of everything. But, making your rounds at the conference and talking to people that are techie at, some of the big ones, not to name any names, these people don't necessarily know the guts and details of how that mining works. They just know that an Antminer does ant mining hashing. So, and then they're building on top of that, of course, controlling it and stuff. But anyway, or their dashboards.
I've had a lot of interesting conversations with miners of all sizes. And I think that there are a lot of the larger mining companies where their specialty is procuring power and the infrastructure necessary for that power for cheap.
Mhm.
And so up until this point, they're like, once they get that set up, it's definitely not easy. Once they get that power set up, it's like, all right, well, we'll just plug in those boxes that make us money. Like our job is done. We just plug in the boxes. And I think we can see that mentality in a lot of these larger miners that are switching to AI. Because they're like, all right, well, there's more money to be made potentially with running these AI boxes. They use the same power. We're experts at buying that. So we'll plug in the AI boxes. But there are the good ones are still that are committed to Bitcoin and Bitcoin mining are still staying in that game. And I think that they are the ones who will see that, owning the whole stack here and having some insight into how that works reduces that counterparty risk. And I think, this is my angle, is that you can make more money. You can make more money when you control the whole stack, because there's going to be specifics about your operation, where your power comes from, when you have to curtail, the temperature profile throughout the year, that if you can more closely optimize for those features, you can make more money.
Totally. I mean, you just imagine if Intel or AMD.
Uh-oh, I think I lost you. Can you hear me? There we go. All right.
There we go. We hung
We're
up
back.
for a second there. Okay, we're here.
We're here.
Did you hear me mentioning Intel, NVIDIA, AMD?
That's right where you cut out. You mentioned.
Imagine if
them.
these companies were like, they work, the outcomes appear correct, they do these functions, don't worry about it. Yeah, we're
It's
back.
ridiculous.
Okay, so, but yeah, I mean, what a business model I have to say, don't worry about that part. They work fine. Well, how exactly do they work? Well, they do everything we expect them to do, but we don't have the specs on them. but they work. Yeah, not a great business model. I wanted to point people, connected through the 256 Foundation, the podcast. You got a regular podcast. Eco and yourself and Tyler on here. Guests, you had Schnitzel on recently. You can go to pod256.org and listen to the podcast that you have here, and regular guests, regular topics. You covered a lot of spicy things. And so that's a good one I wanted to direct people to, as well as a weekly newsletter, the 256 Foundation newsletter. You can subscribe to a newsletter here, get information on what's being worked on and all that. And is the Discord something, if people are really into this and they go to Open Source Miners United, osmu.wiki, and you can browse the wiki, you can connect to the Discord server here. Is this a good resource that you might direct people to learn more about?
Yeah, certainly. 256 Foundation and OSMU are separate but friendly organizations. OSMU was started just completely ad hoc around the origin of the Bitaxe project. And it's basically a Discord server where we all kind of came together and recruited new people to work on this and organized the development of the Bitaxe. Several cool spin-off projects like the NerdQX have come out of this and come out of Discord. There's like 15,000 people on there. It's gotten kind of crazy. Wow. But yeah, so OSMU is mostly the Discord. We are actually trying to transition to a forum. I think if you go to osmu.xyz, you can get to our forum there. We're having a little bit of trouble with kind of the centralized nature of Discord and the fact that it's everything that we talk about there. I think just osmu.xyz for the forum. Yeah, everything on Discord kind of just disappears and isn't really indexed by the search engine. So we're trying to, it's early days, but we're trying to switch over to this forum here
Awesome.
to kind of, preserve for posterity and anyone else who's interested in all the things that we talk about. But yeah, OSMU is fiercely dedicated to open source mining. We've developed quite a few enemies by preventing them from discussing closed source projects on the forum. But yeah, it's very technical. A lot of people, trying to modify, improve their Bitaxes, their miners, developing pool software. Yeah, it's pretty technical, but if you're into that kind of thing, a good resource for people. Bitforge is a cool miner that's spun off from the Bitaxe project, all open source. Someone just taking it and being like, "Hey, I want to do it a different way. Here we go." That's what we love to see.
Yeah, if you're techie, if you're an engineer, if you're a hacker, and you're a positive contributing member of these societies, this is where you can access a lot of info, and also on the wiki as well, you can read up about the iterations of the what versions have come out and as they're worked on, and information about them. And you can learn about all this stuff. So anyway, I like to point people to the resources where they can find this stuff.
Yeah. So there should be links to all the source, the GitHub source pages here, so that you can get in there and start playing around. All the sellers on bitaxe.org, you pulled up that page earlier. These are sellers that there's obviously lots more sellers of Bitaxe, but these are ones that kind of stick with open source principles, and they link to the source on their product pages. I think that's really important, right? So if someone buys it, maybe they don't care about the source, maybe they just want to play it, but I want everyone who buys a Bitaxe to at least be aware that it's an open source project, and they can get the complete source for the hardware and the firmware that it runs. So if they're even remotely interested, there's a very low barrier to finding it. So that's what goes on here with this buy page. I mean, that's the name of the game, right? Is this is a miner that you can just buy and plug in and play the lottery, and have an extremely remote chance of winning the lottery, but come for the lottery, stay for the revolution, which is open source.
That's the thing. People often easily. I was talking with months ago John at Hashing 2 Heating, and he was talking about the heat punks and people that provide consulting and tech ideas and services, and people get into the idea of such mining. A lot of times it's like there can be fiat brain involved, number go up. Oh, I want to mine. I can make Bitcoin. Well, then why not just scale that up? And it's a competitive, hard market. This isn't necessarily something you get into as like a business to really get your non-KYC Bitcoin. It's the ethos of it. Maybe you can collect lost, the heat, but also the learning and skin in the game, and just contributing to what little decentralized hash you can, and just be part of the movement. And then for me, it was something, initially I was like, oh, mining. Yeah, that's cool. Like make a little Bitcoin. And then I realized, okay, that's not really the point.
That's also not really going to happen, right?
And
Bitaxes aren't known for being profitable miners.
Yeah. I mean, I don't know what energy I use. Like, I mean, I don't know, what is it, $1 a month or something, or whatever, but it's not really much. But then it was the tech and learning, and even like templates. It's like, oh, I'm understanding more about Bitcoin generally and the community. And then that, like Bitcoin itself, it leads you to the spirit of, we're all part of this movement, and you dip your toes in the water. It might spur ideas from which you launch other stuff or do other stuff, but it's having skin 100%. In the game, and it feeds your soul in this movement. So I love it.
I mean, it is totally permissionless and decentralized. You can do whatever you want, right? Like with Bitcoin, with a Bitaxe, you can do whatever you want. You can mine some shitcoin if you want. I wouldn't recommend it, but you can do it. But I think, yeah, like exactly like you said, like Bitcoin, it's this entranceway, it's this gateway drug to this whole rabbit hole of sovereignty and freedom and learning and doing what you want and taking control over, over money, right? Or taking your own personal control over money, which is a really important point.
Being part of some of the most important changes we've had in human history. It's easy, and I've said it many times. It's like, the invention of fire, the wheel, the printing press, the internet itself. Thank God for TCP/IP's nature of decentralized access.
Yes.
All these other layers and layers and layers on top of all this stuff. And now with Bitcoin, it's been, call it the money, but it's also more than that. But it's these decentralized type of protocols that just are fixing our entire future and creating a golden age ahead of us. Depending on how much time you have, and you've told your story many, many times, but there is a fascinating piece of this that I thought of leading with, but I didn't want to get distracted from 256 Foundation and the movement and the hardware and all the real meat of what's happening now. But that kernel of initial, the embryo of all this, do you mind telling your story of what made you the instigator? When we were in Prague, great dinner with the Bitcoin Way and meeting new friends. That's where I'd heard of you, and I wasn't sure what all it was that you did until we started talking. And it was a funny walk, a long walk where I had not dressed for. Well, I had packed and dressed for summer, and luckily, I was thinking, it'll be, I don't know what the Celsius is, but it'll be in the 70s. It might be hot. I was lucky to have brought a coat, which was not really much of anything, but I had a light jacket, thank God. But it was raining decently. A walk to the train station, finding our way. The train station's closed. Oh, we got to get a cab or an Uber, and you helped sort that out. But we had some time to kind of wait for that and huddle in the rain a little bit, but it was getting to know you and what you were doing. And that's when it was like, oh my gosh, I have heard of you. I knew of you, but I didn't know what all you had done. And it's an immaculate story, I will just say. But anyway, you're an electrical engineer, had worked in hardware design and circuitry and boards and stuff, and then left California, moved out east. We're tinkering with mining generally. Got yourself, was it an ant miner? I can't remember. But then we're like, how does this work? How does this work? Does anyone know? No, nobody knows. Well, I'm going to start tinkering. So anyway, describe reverse engineering that for the first time to the extent that you want to belabor your story. But we love hearing it.
Yeah, I mean, it started like way earlier when I was still in California, and I had just finished my electrical engineering degree. I specialized in digital design as a part of that degree, and Bitcoin had kind of just come out. I'd heard about it. I was like, I don't know, I got PayPal. What do I need this Bitcoin stuff for? But then I heard about mining and how it uses specialized hardware to do that. It's permissionless. Anyone can do it. It's this decentralized network. And I was like, oh my gosh, this is really neat. I want to try mining. And this was right around the time ASICs were first coming out. But they were super expensive. Didn't have much money. I was like, I'm not going to buy one of those. But I read about FPGA mining, which was a precursor to ASIC mining, kind of around the GPU mining era. And it was totally like, it was open source. Like there was just designs, you could go out there and you could get an open source FPGA miner design. So I was like, okay, rad. Like I want to build one of these. And so I did. And it was
field programmable gate array.
Yes.
Yeah.
It's FPGAs are really neat devices. They're not like Bitcoin specific in any way, but you can think of it as a like an ASIC, but you can reconfigure it with software. It's field programmable. So it uses this specialized programming language called a hardware description language, and you essentially write code, but the FPGA doesn't run that code. there's a tool called a synthesis tool that takes that code and it actually transforms it into logic gates. So the FPGA is just this matrix of logic gates, and then the software can configure how those logic gates are connected.
And it's not as fast as a hard-coded in ASIC, but you can tinker with it.
Yes. Yes. I mean, it can be as fast as a hard-coded ASIC, but it's definitely not as efficient, right? So, you know, an ASIC is a bunch of logic gates, like millions of logic gates connected, like hardwired, right? Like it's fixed.
Right.
But an FPGA is just this blank slate, this whole matrix of gates, and you can just, using software, you can say how they're configured. And that reconfigurability is why they lose efficiency versus ASICs. But it's really cool because you can just try things, right? It's very flexible. You don't have to commit to, like, you know, bajillions of dollars to get an FPGA design made. You can actually just do it yourself in your room. So that's kind of what I did. And it was really cool because there was open source hardware implementation miners available, right? So this is someone who's like done the work to figure out, to write the HDL, and they say, you know, you can just take this and you can load it on your FPGA and it'll start mining Bitcoin. And so that's what I did, right? I didn't like write it. I just got an open source thing, plugged it in. It interfaces with CG miner running on a computer, and it mined Bitcoin. It was really cool. I didn't know anything about self-custody or, you know, withdrawing your Bitcoins from the pool. All the Bitcoin that I mined was lost when the pool got hacked. And I was like, well, Bitcoin isn't worth that much, whatever.
It's not going anywhere.
Yeah, I was like, all right, well, it's gone. That was fun. And I kind of dropped it for a while until a few years later. And, you know, I'd been working in designing my own electronics for different companies and for a while. And I was like, man, I want to make my own miner with these newfangled ASICs. And I got online and, you know, Googled like ASIC miner design, right? Like same thing like I'd done before with FPGAs, but with ASICs. And it's like, zero, nothing. No one's doing this. There was a couple articles of people who had like briefly looked at reverse engineering some old ant miners, which I definitely read very carefully. But it became clear that like no one was really doing this. Certainly they weren't talking about it if they were. And so, yeah, I kind of just set down the process of figuring it out for myself. I got a couple, I actually just got hash boards to begin with. I got some Antminer S2 hash boards off of eBay. I really wasn't willing to dedicate much money to this. And so I got those old hash boards, unsoldered the chips, built my own, you know, built my own circuit board to try and break out the chip and understand how it works. I spent some time looking at existing hash boards and miners to see how they interface with these, taking a look at the software that was on there. CG Miner was out at this point, and CG Miner had the ability to interface with ASICs. And so I spent a lot of time looking at that code, teaching myself how Bitcoin mining works, how to interface with these chips. Around that time, I also, for work, we got a new office, and that office, the electricity was included for free. And, or, you know, as a part of the rent. And so I was like, okay, I know a little bit about this mining thing. Like, I'm going to be this mining god. And so I bought myself a bunch of S9s off of eBay and rewired the power in the office to get the 220 volts that they needed, you know, plugged them all in. I was like, this is going to be amazing. I want to make so much Bitcoins. And then reality set in because they're super loud. These machines are crazy loud. They're also crazy hot. And I was like, it's not that big of an office. Like, I can't exist in this room with these machines running. Yeah, it was like, you know, this was during COVID, and so my coworkers weren't around. But you know, even just by myself, it was like, nope, not gonna happen.
The boss walks in and is like, what is going on in here?
Yes, right. And so I actually set up a script to just run them at night, right, when no one's there. But there's some apartments like above the building, and yeah, it was just a no-go. So I refocused my efforts on making a smaller miner that would become the Bitaxe. And yeah, kept digging into that. It was really slow going at first. It was really frustrating because it's really complicated. These are black boxes, the chips, and just, yeah, it was super frustrating, but just kept slowly working on it.
Turn it on, turn it off. What does it respond to? I don't know. I wouldn't even know where to start, but you just have to tinker, right?
Yeah. You just have to tinker, look closely at other machines, other miners, probe around with the oscilloscope, figure out what's going on. The challenges are powering the chip because they're very power hungry. So you have to provide a low voltage at fairly high current. And then also they have a serial interface to the chip. It's a binary protocol, so it's very obscure, right? Even if I can hook my logic analyzer up to it and see the bytes that it's sending over serial, it's like, well, what do these even mean? How do I send my own work? How do I initialize these things? Right. So there was a lot going on there. The funny story, so I had made this breakout board, like a very early Bitaxe. It wasn't called Bitaxe then, but I'd made this board. I had a single chip on there. I had kind of figured out power, and I had all these pins, right? I was just running wires everywhere. It looked like a rat's nest to communicate serially with the chips. And it was like kind of working. Like even if I played back the same serial sequence that the miner did, it was like not really working, but it would kind of work. Like sometimes I would get some stuff back, but it wasn't working right. And I like banged my head on this for a long time, an embarrassingly long time, until I finally took the chip back off, and I'm looking at the PCB that has the footprint for the chip and the chip. I'm like, oh my gosh, it's not quite right. So what I had done before is to make the footprint for the PCB, you have to, there's no data sheet that says what all the measurements are for all the pins on the chip. So I had just very carefully measured. And when I measured it, I got 0.48 millimeters between the pins. But I'm thinking 0.48, this must just be my measurement error, right? That's 0.02 millimeters. Like maybe I was just off. It's probably 0.5 millimeters because that is actually a standard in the industry to have a 0.5 millimeter pitch, spacing between all the pins. So I just was like, yeah, I probably just measured it wrong. It's 0.5 millimeters. And so that's when I made the board with 0.5 millimeters. Well, it took me a long time to realize it's 0.48. Oh. And my PCB was just slightly off. And so some of the pins weren't making contact. So I was like, oh my gosh, like spun the PCB, 0.48 millimeter spacing, soldered the ASIC on there, and it was like, the thing just came alive. It suddenly worked. Not like it's a Bitaxe and it's mining, but like I'm getting responses that make
Frankenstein
sense.
Is alive.
Yes, it was so cool. I was, this was like late night, and I'm just like super stoked, and like the project was back alive, super interesting. And then I could just take, everything that I had learned and put it together in a board. I wanted to have a microcontroller on there to run firmware, put that all together, made up a couple, and posted about what I had done on Bitcoin Talk. And a couple people reached out and they were like, this is cool. I want to work on this. I have some experience in this. I've also been futzing around with this kind of idea. And so we all got together in what became Open Source Miners United Discord. Oh. And this is when the party started.
Oh, cool.
I took it to my local meetup. We had a hack day at my local Bitcoin meetup. And there's some very talented guys there with lots of experience in the embedded development space. And they were like, we're in. And so I gave some hand-built Bitaxe prototypes to them, and they just started cooking, and it all came together. And yeah, the rest is history. But it was very, very exciting. Like there was just these people that were out there that had wanted to do this really badly, and we all kind of came together on OSMU.
Awesome. And there is that fun hacking feeling, the allure that, you're discovering secrets. There's too many secrets. The world is full of proprietary moded secrets, and we're freeing these treasures that are cooked away inside these little boxes. And by unleashing that, it's like it's more than just the knowledge or discovery. It's a release of a freedom. And yeah, just the energy that you feel when you do that kind of a thing, which I mean, so few people get to experience, because usually it's like, oh, I'm going to take from other things and build something new, say, but there's an extra spice to, there's a treasure inside and we're figuring it out. And when it works, it's like you've tapped into a trove of energy, and it's just,
This is so cool. I feel like you get this. Like, it is hard to explain how exciting this, this hacker treasure hunt is, of getting in there and like discovering the secrets of this black box and how it works, and sharing it with other smart people who are also on the same mission now. And what's really cool is we were able to kind of nerd snipe some people in industry who had been working on miners for a long time. And because we were publishing everything online that we were doing, these people showed up and they're like, well, this is not on behalf of my employer, but here's some pro tips. And they would be
careful about it.
Yeah. It was very, hush hush, but like, here's some pro tips. I like what you guys are doing. And we got a lot of cool information from people who had been working on this, proprietary products for companies for a while. That was really exciting. And I mean, it still is really exciting like this.
There's so much still happening with it all. And also the people start approaching you, like they hear about, once it's got a name, oh, the Bitaxe, the single ASIC miner, or, here's designs and specs and information about all this stuff. And then there's like what I understand would be a rush of people saying, hey, I want one. Where do I get one? Can I have one? And it's like, I don't build these. Did the thought go through your mind of like, wow, do I go all in on trying to be the manufacturer and do all this, like be Bitaxe? Because very quickly it was like other companies moved into this space to help make that happen, and at volume, because it was a kind of a rush, wasn't it?
Definitely. At my previous job, I was responsible for doing a lot of manufacturing, setting up manufacturing, and that's a really hard job. It involves a lot of coordinating different suppliers and manufacturing facilities, and dealing with chip shortages and all kinds of stuff that is just tangential to the engineering behind it. And because I was actually doing that job at the time that I was starting the Bitaxe project, I was like, I'm not going to do that. I'm just going to design this thing and publish it, and someone else can do that job, because it's a whole nother thing. And so I did make that decision early on that it was like, I'm probably not going to manufacture these. I've built a lot of prototypes myself, hand built it. Like, I test everything that way. I think that that's a useful skill for an engineer to be able to build up boards themselves. It enables for rapid iteration. But I didn't get into manufacturing. And right around the time that I was neglecting my day job at the absolute maximum to work on Bitaxe, a friend randomly suggested I apply for a grant from OpenSats that supports, with grants, they support open source Bitcoin developers. And so I went to OpenSats.
The first grant given to hardware, because they were all into, usually it's software, and it was the first hardware grant I think that they gave.
Yes, exactly. I went to them and I was like, do you guys support hardware? And they're like, well, we've never done it before. I'm like, well, it's open source. And they're like, yeah, apply. And so sure enough, I did. And I was very fortunate to be selected for the grant. And right around the time that some other stuff was happening with my day job, and I just parlayed that into full-time Bitaxe development work.
Nice.
And, it is a dream come true. I absolutely love working on it. Maybe I can manufacture these devices in the future. That might be the route to go if this grant funding dries up. But for now, I really like being the designer, or one of the many designers, I guess, of this project right now, and not dealing with that manufacturing thing. There's other people who are very good at that and are making it happen. And I think it does enable the project to be more decentralized.
Right.
Because I'm not manufacturing them. I'm not profiting at all on the sales of them. So there isn't this desire to like sort of keep things secret. You know, there aren't a lot of open source hardware companies, but many of them are tied to companies. And so they do this thing where they will completely design the project in secret and start up manufacturing and start selling them and then open source it. And I don't think that's not the pure form of this. Like Bitaxe, we design in the open. My GitHub is full of projects that have the disclaimer at the top that are like, this is not tested or this does not work yet. So we do a lot of designing out in the open. Has its pros and cons, but it's max transparency, it's max decentralization. And I think that has been really helpful for the project on the open source advocacy side of things.
Totally. Yeah. Absolutely awesome. You were able to emancipate yourself. Things worked out, and having gotten through COVID and all the COVID weirdness, in a way, it gave people a little space and room to focus on some of this stuff. It's just the timing of it, everything about it, serendipitous. And then also knowing the industry well enough to know, I mean, it would be someone's natural inclination to say, oh, wow, there's a huge market here. I've made a thing. I got to make these things, and get sucked into a rabbit hole that takes all your time, all your energy, and your thought process. And then you got a job and the business of all that. It would be its own kind of a grind, and actually kind of limiting to your capability and potential in terms of what's needed here. Not like, oh, I made a thing, let's just number go up about it. You're able to contribute to the community, the space, the designs, where it's all going. There are others that have moved in and filled in the demand for miners, the hardware and the distribution of all that, assembling them. You've got the foundation upon which more and more of that can emerge. And then, so supporting the 256 Foundation, thank you to OpenSats and the other contributors. If I can bring it up here on the 256 page, you can support the 256 Foundation. There's a way that you can direct your, where was it here? You can donate.
Donate in the upper right there.
Oh yeah, well it's there too. So you can fund them, donate hash rate, clicking on this button, click the donate button, 256foundation.org, donate button, fund the open source mining revolution. And there are ways to do that. 501c3 nonprofit, and different ways here. Send Bitcoin directly, donate hash rate, point your pool URL right there. There it is. Pool.256foundation.org, port 3333. Anyway, it tells you how to do it. So, Scott, this has been amazing. I want to direct people where to find you and everything. Is there anything that I didn't touch upon that you wanted to, things popping lately, what you're working on now, where it's going, something that I didn't get to that we should talk about?
This has been fantastic, man. You did your research and are very plugged into this, so I really appreciate it. This has been great. You touched on everything.
Awesome. I love everything about it. Everything that's going on here. Initially it's like, oh yeah, the guest. And as I got to know you, and then realized I didn't know what I didn't know, or things that I knew I didn't know connected. This the story and everything that's going on here was more than I expected as well. When I first thought, oh, I want Skot on because of Bitaxe. I love this stuff, all of it, because it's as important as people focus on the blockchain. Right now, it's a lot about the nodes and the software, everything about that, and Satoshi and the cypherpunks. This is the natural next step, but even a more fundamental layer to all of this, if nodes and miners are separate things, what is it in this ecosystem that makes it run and is all of that based enough? So you're keeping it based, which it's just critical. If we were to ignore this or just take it for granted, we could have software that runs great and be beholden to a ministry of hardware. So we are, we're escaping it in every direction. So I love it.
That's
Hack
right.
the planet.
Hack the planet.
Hack the planet. Okay, people can find you on X here at Skot 9000 with a K, SKOT 9000. Great follow, lots of information. On the board of the 256 Foundation, also on X, 256 Foundation here. Obviously, of course, there is bitaxe.org. Connect with Bitaxe here. All the places on where to get the Bitaxes and the companies that do it. 256foundation.org. They've got a website. Read about them, their mission, how to donate, contribute. Podcast, Pod 256. If you're into this stuff, mining, still learning, want to know what is popping, like even just emerging hot, you talk about it on here. It's a good podcast to follow. Weekly newsletter, sign up for the weekly newsletter, get information about the 256 Foundation, everything going on. And connected with, adjacently, the Open Source Miners United, where some of this all started, the wiki, the Discord server, connect with them there, and stuff offered on GitHub. And hey, to the extent you want to get involved, you can go out there and do things. So super exciting. Awesome story. Awesome work. I'm grateful for your time that you've given me today.
Been great talking to you. And yeah, I really like that message. You know, get involved. There's all sorts of levels and, you know, opportunities to get involved, from running a Bitaxe towards hacking a Bitaxe towards, you know, getting involved from the industrial mining side with 256 Foundation. I will say, careful. It's a rabbit hole.
Yeah. It's a balance of time when you have family or a spouse or a fiat job like I do. It's a careful balance to keep yourself out of trouble, but get your sleep and brush your teeth. So anyway, anyway, yeah, I love the rabbit hole though. So this has been super informative as I continue to learn. I love the hardware and the firmware side. So I'm just can't wait to see what comes next. So thanks for joining us, everybody. I really appreciate it. And
thank you so much for having me
online. It's been great to have them, and we will see you next time. Bye, everybody.